All right, sixth grade, we're getting into some algebraic expressions, and our first set of directions is more of a vocabulary in the sense that it says identify the terms, coefficients, and constants in each expression. Well, the terms are each of the individual numbers. So in this first one, the first term is 5x. The second term is a 4x squared, and since there's an addition sign or a plus sign in front of the 4x squared, it's considered a positive 4x squared. And the next one is 17, but there's a subtraction sign in front of the 17, so the term is considered a negative 17. The coefficients are the numbers that are attached with the x in these multiplications. So our first coefficient is a 5, and our second coefficient is a 4. So we have two coefficients here in this one, a 5 and a 4. The constants are basically the numbers that stand alone, okay? And in this case, it's a negative 17. That would be the constant. That's the only number that kind of stands alone as its own digit. So the constant would be a negative 17. As I go to this second one, we have 28 plus 5x squared plus x cubed divided by 3. Well, I see my terms first of all. I have 28. I have a positive 5x squared, so I'm just going to put 5x squared. And then I have a positive x cubed over 3, okay? So x cubed over 3 as a term as well. My coefficients are the numbers that are connected with the variables through multiplication. Well, here I have a 5 in front of this x squared. So 5 is a coefficient. And this is something a little different. This is x to the power of 3 divided by 3. Well, we remember, and I'm going to come down here, when we would multiply and divide fractions, whenever we divide something by 3, I can be thinking of it as dividing something by 3 over 1. And I know that in division, I have to make the reciprocal, and my division becomes a multiplication. So when I divide by 3 over 1, that's the same as multiplying by 1 over 3. So here I'm multiplying the x cubed by 1 over 3, which means that I have a coefficient of 1 over 3. There's no more numbers attached with variables here. So I have 28. That's a standalone number. 28 is considered the constant. This third one in this example, x minus 7x plus 8y. Well, my terms are going to be x, and then I have a negative 7x with the subtraction sign in front of it. That's a negative term. And then I have a positive 8y. My coefficients are the numbers that go in front of the variables. Well, clearly here I have a 7 in front of that x. Clearly here I have an 8 in front of the y. But when there's no number in front of a variable, it's understood that there's a 1 there. It's 1 times whatever x is, and it's going to equal x. So I have to include 1 as one of my coefficients. When there's no number there, it's like there's a 1. My constant, well, I have no number standing alone. So my constants in this one, there are no constants. So I just put none. Part of your assignment here today in lesson 5.1 will be filling out a table where you're given some expressions. You're going to have to list the terms, the coefficients, and the constants. The second part of what you're doing today, write the expression using exponents. Well, this is x times x times x. So when I write that using exponents, that equals the same thing as x to the power of 3. When I look at this one, I have 5 7/7, or 5.7 times x. Well, I'm going to have 5.7, and I'm going to be multiplying that by x to the power of 2. It's not necessary to put a dot there. Do not use an x for multiplication because we'll be using x as a variable quite a bit. But whenever I have a number right next to a variable, it means multiplication. So I'm going to encourage you to write it this way: 5.7 x to the power of 2. Here I have 8 times y times y times y times y. Well, I can just write this as 8 times y to the power of 4. But really, remember, what I want you to do is not even utilize this dot. I really would prefer you just to write that as 8 y to the power of 4 and have that be the way you show your final answer. In this one, x times x times x times y times y, well, I have x to the power of 3, and I'm multiplying that by, there's 2 y's, so it's y to the power of 2. But once again, I'd rather not you have a dot there, and you should always have your variables in alphabetical order. So we should put the x first, x to the power of 3, y to the power of 2. As variables right next to each other mean multiplication. Final set of directions you're looking at today: evaluate the expression when a equals 7, b equals 4, and c equals 16. So once again, evaluate the expression when a equals 7, b equals 4, and c equals 16. Well, my first one says 7 plus a, so I go back to my directions and it tells me that a equals 7. So all I'm going to do is plug in 7 for a, so it's going to become 7 plus 7. Well, 7 plus 7 is 14. When I go to number 2, it says c minus 13. Well, in my directions, it tells me that c equals 16. So I'm going to take this 16, I'm going to plug it in here for c. That means I'm doing 16 minus 13. Well, 16 minus 13 is 3. A number right next to parentheses means multiplication, so this is a times c. Well, a equals 7, c equals 16. So off here to the side, I can just do 16 times 7 and figure out what that is. Because c is 16, a is 7, that's what it says right here. 7 times 6 is 42. Put the 2 down, carry the 4. 7 times 1 is 7, plus the 4 is 11. I get 112 as my final answer. Here this is c over a. Now remember, a fraction is just a fancy way of writing a division problem. C divided by a. 16 divided by 7. I get 16 divided by 7. So I'm going to rewrite that as a fraction. 16 over 7. If that's in simplest form, I can just keep it that way, and there is no number besides 1 that can go into both 7 and 16. If I want to turn it into a mixed number, I can. 7 can go into 16 2 times. If I take 7 into 16 2 times, there's 2 left over. My denominator here is 7, so my denominator here is 7. If I want to make it 2 and 2/7, I can, but as long as the fraction is in simplest form, that's fine. Next one says 6b. Now, anytime we have a number right next to a variable, that means multiplication. 6 times b. So if b is 4, as it says in this problem, this is 6 times 4. Well, 6 times 4 is 24. And so this gets me to the last one, 7a plus 3b. Well, this means it's 7 times a, and this means that it's 3 times b. Well, a equals 7, so this is 7 times 7. Well, 7 times 7 is 49. And this is 3 times b. b equals 4, so this is 3 times 4. 3 times 4 is 12. So I can just come over here, do some quick scratch work for 49 plus 12. 9 plus 2 is 11. Put the 1 down, carry the 1. 1 plus 4 is 5, plus 1 is 6. I get 61 as a final answer. All right, talk to you later, 6th graders. This is lesson 5.1. Bye.